Navier-Stokes exact solutions morphologies behavior in pipes and coaxial cylinders using simple closed forms. Introduction. In the present investigation we have considered the flow in pipes and between porous rotating cylinders. The effect of suction and injection is studied on the walls of pipes and of the cylinders. Several authors have analyzed 1, 2, 3, 4, 5, 6, 7, 8 all these flows for the Navier-Stokes equations for incompressible flow, written in polar coordinates. In a new attempt to resolve these equations strong analytically with closed forms, according to an Polyanian-Aristoff assumption 9, it is assumed that the effect of the body force by mass transfer phenomena is the porosity of the porous boundary in which the fluid moves. The effect of porous boundaries on the viscous flow is examined for two different cases. The first one examines the flow between two rotated porous cylinders and the second one discusses the swirl flow in a rotated porous pipe. The developed solutions are of general application and can be applied to any swirling flow in porous axisymmetric rotating geometries. The exact solutions are obtained by employing the Bessel functions for the case of three-dimensional unsteady flow between rotated porous cylinders and for the case of unsteady swirl flow in rotated porous pipes. Mathematical and physical modeling. For the first case study we assume the flow of a Newtonian fluid within a rotating porous cylindrical pipe, figure 1, and for the second case study the flow through an annulus formed between two rotating porous cylinders, figure 2. For the two cases, the basic equations are the mass conservation equation and the equations of motion, Navier-Stokes, in a cylindrical system of coordinates rz where the z-axis lies. Conditions in a rotating pipe. Figure 1. Flow within a rotating porous pipe. Axial flow conditions in two rotating porous cylinders. Figure 2, rotating porous cylinders. Governing equations. Considering that the flow modeling describes the motion of a homogeneous incompressible Newtonian fluid, the Navier-Stokes equations have as follows. One-dimensional flow in centrifugal pumps impellers. 4 exact solution sets and their own boundary conditions. The exact solutions the boundary conditions. Time-dependent swirling flow in a rotated porous pipe. IME-dependent axial flow between two coaxial porous rotating cylinders. The exact solutions the boundary conditions. Derivation will appear in the next publication of the authors.